this video we are going to focus on nonlinear relations. The parabola. Relations that have rules in which the highest power of x is 2, such as y equals x squared, y equals 2x squared minus 3, or y equals 3x squared plus 2x minus 4, are called quadratics and their graphs are called parabolas. Parabolic shapes can be seen in arches, bridges, and paths of projectiles, such as an arrow being shot from a bow or water from a fountain. As you can see here on the left-hand side, this is a parabola shape, and it can be up or down in the way it appears. Let's take a look at these two examples here. We have a concave up smiley face shape, which means the arrows are on the top, and it looks like a person smiling. And we have an axis of symmetry that runs through the center of this, and a minimum turning point is the very bottom of the smiley face, and it connects through the center of the axis of symmetry. On the other side over here we have a concave down, which is like a sad face. We have the sad face, upside down with the arrows at the bottom. The axis of symmetry goes through the center, and the maximum turning point is connecting through that. So the highest point in the sad face is through the center, and that's the maximum turning point. So the turning point is minimum when it's down low in the low part of the smiley face, and the maximum is the high point of the sad face. What we have here is an example. It's not calculating from the equation here, it's the answers that that equation would have given us. So I'm not showing any calculations, I'm just showing you what it would look like. And I have enlarged it, so we only needed part of the Cartesian plane. So you can see here it's only a quadrant of the Cartesian plane. And what this equation would have given us is more points than 3 that have been shown plotted on this Cartesian plane. It would have given us more based on how many the table asked us to find. Quite often they ask you to find 5. So I've just got 3 points here for us to have a look at. And these 3 points are the ones that intercept the x and the y axes. So taking a look up here at the y-axis, this plot, this coordinate, was passing through the y-axis. That's why we call it the y-intercept. And we have 2 here for the x-intercept that pass through 1 and 3. So we get this nice smiley face shape. And this is a minimum turning point because it's a smiley face shape. And the vertex sits smack bang on the axis of symmetry. So this is like, if you fold it in half, it'll sit perfectly on each other. That's why it's called the axis of symmetry. And where the turning point is, which is the vertex, tells us that x equals 2. And the reason we get x equals 2 is because it passes through the x-axis of 2. Let's now take a look at this question. We have been given an equation that says y equals x squared minus 4. And we've got a table of values here, and the value of x has been given to us. We need to calculate what the value of y is so we can plot our coordinates that we're going to create from this table of values. So we have this equation, and the x must be substituted for the value given in the table. So we're going to use our calculator to do the first one here. Replace x for -2. So we go brackets, the positive negative button, which really means negative. Number 2, close the bracket, the squared button, minus 4 as indicated here, and equals. And if you calculate that, you get a value of 0. Now if we do the same thing for the rest of the table, and instead of putting in the 2, you place the number 1 in here, we can get an answer of -3. When we get to 0, 1, and 2, we don't need this button. This button's only been put in here because it's told us to in these two x values here. So we would then just substitute 0, 1, and 2 in this section here, but not this positive negative button, which indicates for a negative number. And then if we kept going through, this is what we would get: -4, -3, and 0. And you can already see a pattern here. This is going to give us that parabola shape where these two are the same, These two are the same and this one is different. So if you don't get the answers that come up with this pattern, it means that you have made a mistake. Now I need to write all the coordinates out from that table of values. So reading here, it's -2 and 0, -1 and -3, 0 and -4, 1 and -3, and 2 and 0. You can see the pattern that's transferred down into the coordinates, because not only does the bottom of the y have that sort of pattern, so does the top part here for x. Let's now go ahead and put this into the Cartesian plane on the right hand side. I'm going to start with the left hand side here, and we're going to plot -2 and 0. So we go on the x-axis first, and we go to -2 and 0. We don't go anywhere from there, just -2. So we've got a x-intercept there. The second one is -1 and -3. So x is -1 and the y is -3. So try and neatly put that down there as best as you can. I haven't got the grid here to help me, so I'm just trying my best. The next one is 0 and -4. So we start in the origin, we stay in 0 and come down -4. And now we can see that if we get the next coordinate, which is 1 and -3, so 1 and -3, we're now coming to finish off our smile. And our next one is going to be on this number here, which is 2. So we have a 2 and 0. And now we're going to connect that to make it a smiley face. It's not the easiest thing to do on a whiteboard. Probably even not that easy with a pen, but you do your best. So I'm going to try and start joining it from the right hand side, coming down to the turning point. Oh, it's not looking that great, but you know what I'm doing here. And they've got to go past. And we then put our arrows on the top. So try and do it in one go. I wasn't able to do it in one go on here. So now we have our smiley face. We can also read from this. So I'm just going to get a different colour pen, purple, and I'm going to identify what I can see on this. So our turning point is 0, 4. This is our turning point. Turning point, and that is a coordinate of 0, 4. Oh, -4 I should say. And our x-intercepts are here. I'm going to draw some, our x-intercepts, because there's more than one. Our y-intercept is down here because it's crossing through the y-axis. And we have a minimum turning point. So this here is minimum. So it's a minimum because it sits at the bottom. The smiley face sits with the minimum turning point at the bottom. And the axis of symmetry, which is a little bit hard to draw in here because it's right on the x-axis. So if I was to draw it, it would come through here. It's a bit difficult to see, but you want to draw it as close as you can, pretty much on top of the x-axis, but I'm drawing it beside it so you can see it. So this dotted line here, I'll just draw an arrow to it, is the axis of symmetry. And you will have to label your Cartesian plane after drawing your parabola on it with these sorts of things. So you need a turning point, which is 0, 4, or 0, -4. It's a minimum turning point. You need an axis of symmetry, and you need to also label your x and y intercepts. In order to do that nicely though, just please remember when you are drawing the curve shape of your parabola, please try and draw it as smooth as possible. Mine here is a little bit rough. It should be a bit more curved at this vertex down here, but I'm sure you can do a better job than I have on the whiteboard.